G'day. Welcome, or welcome back to episode 7 of Whether or Not, otherwise identifying as a big old follow-up to our last episode, which was a big old follow-up to the episode before that. Yes, Australia, we're not quite done with you just yet. You might want to reboil that billy or stick another prawn on the barbie, eh? That's a shrimp for you starry stripy lot. I am Stella Q and, well, I know a guy who just can't help himself. Just when we thought we were done with that tantruming sky and all its tropical winter outbursts, Jeff goes and finds this whopper of a sky thingy, and he'd like to tie all this together and bring any mysteries out of the marine cloud brightness. What else could this be labelled as, other than a sky tsunami? You'll see. Yes, Jeff managed to catch the cloudy culprit with its big thunderhead pants down. All from one of the many eyeballs in the sky. One of the friendlier ones, I think. But before I go off on a TM tangent, I think we better dive right in. So here we go again. In pursuit of the plain truth, join us as we dive deep into the big sky with an even bigger question. Was it weather or not? And as a follow-up to our previous Q&A session regarding the heavy storms that we had on the east coast of Australia, New South Wales and Queensland, there's a little bit more to that story, it appears. Jeff, what say you?
I say we kind of concentrated on the main part of what we were trying to show in the previous two parts was cloud seeding. And we investigated a couple of aircraft. And we mentioned the rain that was coming. That was kind of unusual, but we didn't really dig into it. And I wanted to go through it and figure out what caused that. I knew there was a high pressure center out there with the easterly flow off of the Atlantic, and I said that. But we came up with some interesting looking videos, and Stella came up with this great name because you'll see why in just a second. It's called Sky Tsunami is the name of the title of this episode, and it is incredible when you see this video. So right off the start, I'm just going to show you the video, and then I'll get into the ins and outs of that and how I investigated this. So
okay, so let's talk about the dates.
Okay.
What dates are we looking at here? Because
So
the date of the
is
big downpour in New South Wales and, well, Brisbane, I guess, Queensland, was around the 10th, the 11th, and we were basing our last investigation on a few days prior to that.
yes. So we started looking at the 7th, those two aircraft first in Tnuth and Newcastle, where we saw the cedars, and we went over that. This is going to be looking farther north, up to Brisbane and north, primarily where this all happened between Townsville and Brisbane, which I'm showing you here with the cursors. Brisbane's right here with that peninsula out there. That's north of Brisbane, and Townsville is far up to the north. What's the terminology for that peninsula, Stella?
Cape York sort of area.
Okay. So this starts on the 9th, so it's early to show what's normal. And then you're going to see this weird stuff. This is from the 9th to the 13th. This is about 4 days of August. Yeah. So I'm going to play this and let the picture be worth a million words, and I'll say less because of it. Maybe. Here we go. So watch this. So you got west to east flow, which is normal. You can see everything moving across. Then you see this circulation off to the left over by Windora. And then you see this explosion. Yeah. These are 1 hour apart.
It's monstrous.
So that's showing high clouds, the cold tops. Minus 40 is red degrees Celsius. Minus 45 is the blue color. The dark blue is minus 50. So what that's telling you is you have rapidly cooling tops. I'm going to play it one more time because it's like a waterfall.
Can you? Yeah. All right. While this is playing, the orange part that we're looking at here. Just
That's
explain that.
warmer, lower clouds or no clouds.
Okay. So this is being pushed in by a warmer front, or what do you call it? Warm
Uh,
high pressure.
you have up to the upper right corner, you have what they call the intertropical convergence zone, which is equatorial moisture, and somehow it worked its way down here. And I'm going to explain how that possibly happened and how it made all this work.
Okay. So what are we looking at right here? This is clouds?
Yes. So these are the cloud top temperatures. And I'm going to back up to the place where it initially starts. So it really starts to go crazy up by Townsville, right about now.
Boom. Yeah, look at
right
that.
Here. That just erupts. It looks like fireworks.
Can we put? Yeah, that's what I was thinking. Can we zoom in a little bit on that, please, Jeff?
It looks like literally an explosion. And if I play again, it gets worse. So you're starting to see all the cold tops in the upper right corner, and they're working their way south. And here we go again. It explodes first time. You're starting to see a circulation over here by Windora, a turning in the clouds clockwise. This is southern hemisphere.
Yes.
So everything's going around it to the clockwise direction.
Yeah, you guys are backwards.
Yep. And the explosions continue out into the 13th. And eventually this stuff clears out to the south. Now I can show you another view. Surface to 500 millibar or 850 millibar. This is like 5,000 foot. Surface to 5,000 foot moisture, which shows it better. You got all the yellow up here, which says that's 30 millimeters of moisture at each location. It's yellow. When you get down into the purple, you're getting down to 15 millimeters of moisture between the surface and 500,000 feet. And when you play this, you can see the same thing, but it's a little wider out view.
Can you just explain that? I'm sorry. Can you just explain that a little bit more? When you say 15 millimeters of water between the ground and certain distance, what do you exactly mean by that?
If you measure like a cubic meter of air and weighed the water in that cubic meter of air, that's what it would weigh.
Right. Gotcha.
So 15 millimeters, that's what, 1.5 centimeters, which is half an inch or a little bit more than that for non-metric people.
Around about that.
And every location that's in there with the yellow has 30 millimeters. So it's really, really wet, and that's along the equator. What happens here is some of that pushes down towards northeastern Australia. And I'll play that loop. So this is just a 5,000 foot level, and that measures the amounts. So you see this big surge right down the coast. And this ends on the 15th. So this goes a couple days, until yesterday, I guess that would be. So let me get out of that now. You've seen the pictures well enough.
Before you do.
Okay. Sorry.
I miss you by that much. That's all right. I was just going to I wanted to highlight the bottom gauge there at the bottom.
Okay.
Just so that people can sort of see the very high level is yellow going down to the orange, down to the purple, down to the blue, and less down to zero.
Yes. And the red is where you're having about 20 millimeters. So 3/4 of an inch of rain.
So is that considered a lot?
Moisture. In the bottom 5,000 meters, yes, that's significant. This is a tropical push. I call it a tropical intrusion. It's not a tropical storm. I mean, this is just going to show what you can get from warm, moist air pushing down somewhere, and it's interacting with a cold area coming from the south. You get these things happening. Severe events like this happen when you get 10 or 11 inches of rain, when you have cold interacting with warm. That's what does this.
So the reason that it's called an intrusion is because it's sort of not following your regular path? Would that be?
I'm calling it an intrusion.
Okay.
It's not even called an intrusion.
Oh, okay. No, it should be.
It should
It's like,
be.
get
They
back
should have
there,
a name
buddy.
for that. Yes,
You're in
they
the
should
wrong
have
place.
that name. So
They should.
so right off the start, I went and looked farther north than the area we looked at the other day for aircraft. I wanted to see, why would somebody do cloud seeding here, first of all? Did they? So I looked at it and I set my filters up again, just like I did with the previous episode, looking for king air and 12 to 20,000 feet. So I've got a wide range right there above the 15,000 that I expected based on what I saw on Ventusky for temperatures. So when you don't have a filter on, that's how many aircraft are in the sky. As soon as you turn the filter on, they'll go away.
Boom.
And if I play from right here, from this time frame, which I'm just picking on the 10th, when the first rain was kind of coming in, just getting to shore, when I play through this, I hit the high speed and 300 times speed, and you could see the sun is coming in from the east. The sun is rising. This is daybreak on the 10th. But this is actually the 11th because you have to add 10 hours to the time that you see.
Yeah, 10 hours ahead of UTC is our time.
Correct. And this is 1950 UTC. So you're the next morning, a day ahead of London.
Yep.
So the sun's coming in. So I want to pause that right there. And I'm not going to show you this because it's going to show you a lot of nothing. There's a couple aircraft that come up and I can click on them. There's the count up here. As soon as one comes in, it will show up in the view number.
Oh, okay.
There's 13,000 flights globally at that moment. Most of them are ADS-B. Some of them are spaced ADS-B measured.
What do you mean by ADS-B?
That's a way of tracking aircraft from ground transmitters. Some people can actually become a part of ADS-B and add to it by buying the gear. And here you go. You got an aircraft right here. So that one's a Beach King Air, which showed up because of my beach filter, my King Air filter. And then it goes away. And here's another one. And it's probably also Beach King Air. This is a Piper Malibu. It's in the flight range that I specified. It's between that level of, it's showing 00. Anyway, it showed up for a second and went away. But I don't want to spend a lot of time on this. We did this in the last episode. Yep. I'm just going to tell you, I went through and looked at this entire area for those guys, for cloud seeding. So I'm going to get out of that and go to.
So the King Air, the King Air bit in the filter, is that's the only thing that would cover the cloud seeders? There's nothing else that would cover that?
This right here too, the 12 to 20,000 feet.
Yeah. But there's no other planes that you would choose? Drones? What about drones?
Well, they're in this filter. So like if I show you right here, drones are on it.
Okay, I see. Right. You don't have to
I'm looking at all these types in this filter that I have set up.
Okay.
Okay. So put that behind us now. It's like, can any other weather modification method be a part of this? And this is from Jim Lee's website,
climateviewer.com.
And on the right, he's got this beautiful graphic here. And is it an ionospheric heater? Is it a sounding rocket? Is it a satellite? Is it a laser? Is it cloud seeding? That's number 5 we're looking at, cloud seeding. Cloud ionizers, stratospheric aerosol injection, ship tracks, contrail induced cirrus, water vapor pollution. Could possibly be 9 contrail induced cirrus. No, it's not. Has nothing to do with that. All those clouds you saw there are mega scale.
Yeah, so on that graphic, I'll just point out, number 5, cloud seeding. In this case, it's actually ground-based cloud seeding that he has there.
Yes, that transmitter-looking thing, that's acetone. And you put that on the windward side of a mountain, and it pushes it up to the top with the ascending currents from the water surface that it's coming across. So
in other words, sorry, I just wanted to point out, so in other words, there's various ways of cloud seeding. It's not just from a plane.
Yes.
Just so that in case people didn't know that.
They can use propane. They can use acetone, and there are projects all over the western United States that show or that have these generators set up at the base of a slope.
Oh, well, they started out using dry ice, didn't they, in the very early days?
I believe, yes, that was a long time ago.
Mm.
It'd be a lot better if they used it.
I'm not that old, but I've just heard. All right.
Okay, so I'm assessing for this stuff. So that tsunami caught my eye to the point where I had to really dig into it, being the weather guy that I am, the weather geek that I am. So I started looking, first of all, what's really happening. So I'm looking at the news stations in Australia, and I'm seeing
Are you
intense
okay?
rain in Queensland, flood watches, severe weather updates. This is 13 August. Heavy rain and flooding for southeast Queensland and northeast New South Wales. And they're showing this area that I pointed out on the early map from Brisbane up to the north is the worst. And if you play this up, just very, very briefly, you're not going to hear the audio, and I don't want to hear it either because it's distracting.
Neither do I.
But this was not missed by anybody. This right here forecasts up to 250 millimeters expected in Brisbane, Gold Coast, and Sunshine Coast. And they show maps on this as well that they show what days it's going to be worse. So they did not miss this. This is not a surprise. They show a couple charts right here, I think, in here. Let me find them. Here we go. Where it's going to be. And with time, Wednesday, Thursday, as it moves south, they hit this thing perfectly. So that said, now you dig into some of the numbers. And this was as of the 15th of August. I don't know where all these places are, but when you go to the links, you can find out where they are. But that is what I'm pointing out. They called for 250. They got it in two places up to the 15th. And if you scroll down this thing,
I'm always suspicious when they get it right.
Yeah, it's like, what? Weathermen are not supposed to get it right.
How did you know that?
But you could scroll down and scroll down and scroll down, and there's a lot of numbers that are, 100 would be about 4 inches.
Yeah, it's still quite a lot though, isn't it?
That's a lot of rain. And especially if it's not tropical storm. This is over a couple days, but it's
exactly.
Like somebody here in the group and the Climate Bureau group said, he said that's kind of abnormal for this time of year from a tropical thing, because here in the northern hemisphere you get the tropical stuff in the fall, and because we're opposite of southern hemisphere, that means you should be getting it in the spring, and it's not the right time of year. You're 6 months off for getting tropical stuff.
Yeah, we're sort of in our last month of winter now. It's actually been an incredibly mild winter, I can tell, because the choco leaves never fell off.
You shouldn't get this time of year. And
no, not really.
The question is why. So the interaction, I'll go over why here, but let me show you a couple other things. This is the Ventusky precipitation monthly anomaly chart. This I went to the 16th, and you could see it's got a large area along the coast between Brisbane and north of there. That a part of it actually hits 200 millimeter anomaly. So,
right. Okay.
And then if I go to, there's the flight radar that I took a picture of, and this is what's causing it. So you have, I'll show you the other chart on Ventusky again. There's a high pressure center out here. This is the Jetstream.
Okay.
For this part of the world right now, and there's this trough of low pressure extending from down near Tasmania heading to the northwest. This is what interacts with that moisture, and I'm going to go in and show you. I think I might have one more picture right here, that it forms a circulation center as that approaches the west coast of Australia. So what happens then is
so you're saying that the rotation is sort of being fueled by the low pressure system? meeting the high
Yes.
pressure.
So that,
Okay.
okay, here we go. So here's the live Ventusky at that moment, which shows the trough heading to the north from way down somewhere near Antarctica. Protrusions, it's a protrusion to the north. This counterclockwise flow is high pressure up here. And what happens is, I'm just going to jump forward in time as this, from the 9th, it gets closer and closer to the coast. And as that gets to near the coast where you have warm water, you have warm water below 23 degrees Celsius water. And as this pushes up towards Brisbane, it initiates at lower levels a circulation, which I try to hit 700 millibars right there. It initiates a circulation center somewhere north of Brisbane. And as that time progresses on, that translates down to the surface. And you can see this is 700 millibars. And then I'm going to go to the 13th when the major rain hits. This circulation center is located right here, 7th on the 12th. Let's see, I want to zoom in a little bit and go a little bit lower down to the surface level. And you can see what it does to the winds at the surface. It intensifies them. Let me go lower, 250 millimeters above the ground.
So low down, it's intensifying the wind.
Low down, it affects what's down there, down below, and it creates a funneling effect. This is the circulation center that translates down to the surface, and it continues to increase those surface winds and give a huge push of moisture inland. And if you quickly look over to the radar, you could see that the that moisture that's offshore goes around that low pressure center and pushes it right into the area near Brisbane. So that's like the big picture view, and it's reflective of what happened as far as where that rain went.
So are you saying it sort of got concentrated
Yes.
all in on itself kind of thing? It imploded almost.
Exactly. If I went back to the 11th again and went to the mid levels of the atmosphere, let's say 700 millibars, which is around 10,000 feet, you can kind of see this thing, how weirdly it actually formed up. So you start seeing a circulation, and I'm going to jump forward in time like 3 hours at a time. You can see this low spin up and get stronger and stronger winds, and those are reflected with the numbers on the right. When you get into the yellows, you're at 35 knots. And you could see this thing continue to work towards funneling that air in south of, I think it was Rockhampton. When I zoom in right there, yeah, it was Rockhampton. So I've got a zoomed in picture right there. And if I continue to space my way through that, 3 hours at a time at a jump, you can see how the winds pick up. It gets darker and darker colors. You get into the oranges offshore, and that's 40, 45 knots pushing into the surface, or at 10,000 meters, or 3,000 meters, 10,000 feet. And you can see that funneling happening, and the radar has to go along with it because that's where the clouds are. So you start getting this stuff rotating in south of Rockhampton, north of Brisbane.
So it's sort of like there's more and more force building up?
It's
like
concentrating it in one spot, because it has to go around that circulation.
It's sort of like ringing the sky, I suppose, wringing it dry sort of thing, like when you wring something and then just like it gets too much and the water has to come out.
Yeah.
Would that be a fair comparison?
Well,
if one could do that?
You have terrain south of Townsville. First of all, I forgot to put that map back up, but there's terrain here, number one. You have
can you define terrain? What do you mean?
Terrain
when you say
being
that?
1,000 meter, 500 meter hills that gives it a push.
Mm-hmm.
I have this other, I want to get this other chart in here. I'm going to resize this to where you can see This is just before daybreak. On the right here is where I'm showing you right now.
Yep.
So just before daybreak, this is just another view of looking at what happened.
Yep. So we're just so everyone knows, we are looking at the northeast part of Australia in Queensland, northeast of
Yep,
Queensland.
Brisbane is right here. So the sun comes up, and you'll see the brightness here as I click forward through this. So that stuff starts right at sunrise. Those things start kicking up because you're heating these hills. When that sun hits those high hills, that starts your convection. So not
Of
only do
course.
you have of the hill itself, which is something that causes cooling because wind going up a hill has to cool adiabatically, is what they call that. That
Yep.
was touched on in the Cloud 2 video on
Of
how
which
that works.
the links will be in description.
And then the sun comes in, and then that trough rotates in, and that trough is right here, that low pressure trough that was extending from down here. And I actually have a nice video explanation of anybody that wants to understand how that Jetstream interacts with that. And it'll be in the links rather than
Okay.
showing it right now. But it shows how that happens physically, and it's a short video, but really good. So just take it for, we want to keep this semi-short today, right, Stella?
Preferably.
We're already 2 hours into this these two videos prior to this. So
Yep. Well, we do
um,
go into great lengths. I mean, that's why we're called forensicists. Well, you are.
yes,
I'm just the dumb question asker. So, here's a dumb question. Speaking of dumb questions, actually, no, there is no such thing as a dumb question. I do
there
jest.
isn't.
No. Anyway, what would be the difference between this happening with such round pressure going round and round and round and building up? Why didn't a cyclone happen?
Well, I mean, you see
What's the
those things
difference?
coming. First of all, it's wrong hemisphere for this time of year. If you look down here, there are none on the southern hemisphere. If you look up here,
No, it
off of
would have been
Japan,
unusual, but then so is this. So,
I think it's off season for them. They belong up here by Japan right now, and
yeah.
probably over in the Atlantic as well. Ernesto's over there. You got three of them. Yeah, you have three happening in the northern hemisphere right now. So it's just not the right time of year.
Well, yeah, I know, but like probably in about 3 months is more the right time of year for us. It's usually around Christmas. Um, so, but then this is an unusual thing, and it's also been such a mild winter that it wouldn't surprise me, if something like that did happen out of character. Because
Yeah, what
things have
just
shifted a bit
happens?
with this whole solar cycle business.
Yeah, I don't know how much that has to do with it, but you can, if you just look at the big, huge, far out view right here, and I click back in time a little bit, you can see this moisture that's associated with that intertropical convergence zone. It's mostly up here. That
Yep.
trough is coming across the state or the continent of Australia. It's out in the middle right here, where you could see this wind flow that has a upside down V.
Hmm.
And as that comes in, along with sun coming up, hitting the hills, a strong high pressure center counterclockwise rotation offshore, pushing all that moisture in, all those four things converged. Well, the trough, the high pressure with the easterly flow. We could take a quick look here at the moisture. So this is the morning of the 12th or the 14th. I want to back up a little bit and just very quickly show you that
Look at that.
the the SQT, which is your radius-on data for Brisbane. So I only took it back to the 11th, but you can see there's good moisture up to 800 millibars, which is about 2,000 meters at first. A big dry area, some more high clouds up here above 400 millibars.
Hmm.
And then you go to the next one, and you can see how this changes in time. It gets wetter and wetter. You still got a dry area here and a dry area here. This is the 12th on the 12th, 12 Zulu. So add 10 hours again. So this would be 2200. Okay, so it's getting closer and closer to when that rain really gets there, because this moisture is going up to the tropopause now, up to 34,000 feet.
Yeah, it's about
And
10
then
a.m. Brisbane time.
and then you could see it got even wetter, where
Mm.
temperature equals dew point for the whole bottom 11,000 feet. And you could see what the winds were up there. They were westerly way up top above the tropos, up in the stratosphere. They were northerly for a while, and then they're easterly right here, pushing all that stuff down towards the coast from the northeast.
All right, just
So,
while we're here, never fear, folks. We are going to do a very detailed radio sonde episode at some point because I know Jeff's itching for that one. And we will get him to explain what these Viking runes really are.
yeah, we're just trying to just skirt the edges on all this stuff right
Yeah,
now.
at the moment.
The people that are really interested in the radiosonde stuff, there's been plenty of mention of it so far to where those people would be the ones that are there to view it when it finally comes out, and it's going to be hopefully in less than another month. But we get so much information out of the radiosondes. It is the basis for all this, and you can see how the winds are from the southeast, parallel to the coast at first, early on in this period, and then they come up and they're pretty weak out of the west, and then they go to the north, and then normally above with your high cloud movement up below the troposphere, these high clouds are coming in from the west. And as you move forward in time, those upper winds stay out of the west. And then this onshore flow from the Atlantic, where the warm water is, you have 20 or 30 knot winds right here just before all this stuff really gets bad. And 30 knots solid right here. Each of those lines is worth 10 knots each. So that's a 30. And this is at 700 millibars and 25 knots down here at 1,000 meters. So on the 13th, where you have all that moisture, you have 40 knots here below 700 millibars, below 10,000 feet, and 30 near the surface, and totally moist air, and pretty much solid clouds all the way up to 35,000 feet. And then you hit the tropopause, and it warms up, and it dries out instantly. It just completely caps off that, because this is an inversion.
Okay, so when we saw that initial sort of explosion where it all just went, I can't take it anymore, poof, what would the radio sonde have looked like then at that moment?
That was 10:18. Do I have one that early? I don't think I do. 10.
Would it sort of look like that? Like where it's
Okay,
just wet and
I'll
then
just
suddenly...
go get it. I'm going to back this up a little bit here. So let's say that's I'm going to go back to 9:12 and go to Brisbane. I have it set for skew T. This is on the 9th at 12Z. There was not that much moisture down here. You had a whole bunch of little inversions and a little bit of moisture where you had clouds probably right here. So this is after the cold front went through on the 8th or 7th or whatever it was. That's way offshore at this point, leaving some moisture behind. And then as you go through time, it's still pretty dry right here. This is on the morning of the 10th, 11th. And the moisture increases as you go through time. It continues to moisten up. Let me try to find it here, because this is which chart? This is the 500 to 300 millibar level. So this is 18,000 feet up to 30,000 feet, and west to east flow. It started right there, approximately there. And that time
That's the
is
11th at
11th
10
at 0. It was a little
UTC.
bit before that. I would actually have to back up, because it started low. That was the low clouds exploding with the sunrise. And then it worked its way as that trough came in. That kept on working its way up because the atmosphere was unstable, and it made that explode.
Okay. So it was the convective heat and then also sort of hitting the terrain that just made it all too much for it, and it just went boom.
Yes.
Yeah?
Yep.
Okay.
And that deep easterly flow that we saw on this stuff right here a couple days after this. So you can see these are just southeast at the surface, parallel to the coast, westerly above. And as you see, everything switch around. Now you have a deep easterly flow by the 11th at 12 Zulu. And then it continues to stay easterly and strong as you go into the future, where it's moistening up everywhere.
So it sounds like it was just a perfect mix of lots of different things into the recipe that was just all too much.
Pretty much a
Extreme
one of your perfect storms.
Yeah, well, there you go. Well,
literally.
Sky Tsunami.
Sky Tsunami. I think I showed you all the charts I wanted to show you. Oh, here we go. You can back it up right here to where that all started. That's where the fireworks started right there, which was just before sunrise as that trough was approaching. There's that spin. Here we go. Tsunami. This is not at full speed though, like that video was. This is relying on my internet right now. It's choppy.
Yeah, at best.
And as that trough pushes to the east, it pushes that moisture south and offshore.
And because, I mean, the ocean's temperatures seem to be quite warm at the moment, considering it's winter. What did you say? Around 23. About 23. Yeah. That's fairly warm.
If I go back to this, you can see
I don't know what's normal this time of year, but it sounds warm. I mean, I'd swim without a wetsuit.
Here's your sea surface temperatures right here. And 22s and 23s and 24s, 25 way up north, up off of that point, whatever you called that, at the equator, 31. Down here off of Sydney, 20.
Yeah, right. Okay. Well, it's still fairly warm.
And your circulation patterns are out of the north along west coast or east
Celsius,
coast.
Of course. Celsius, we're talking, of course.
From not out of the north, they're from the equator on the east coast of continents, and from polar regions towards the north in the southern hemisphere. Here, it's opposite. Everything is opposite. Northern hemisphere, southern hemisphere, but west coast, east coast, in the northern hemisphere, circulation is from equator to north.
Yep.
Same thing down here, from equator to the north on east coast. West coast are the opposite.
Yep. All right. Okay.
So you got warm water coming to the south. You could do a little assessment right here. Just look at it like this. Here's Taiwan right here, and my big hand right there doesn't allow me to see 32. And over here off of Baja, 24, 23, same latitude, versus Washington State, 16 versus
20-something. The big hand is in the way.
You got Japan kind of gets in the way right there too. So like if you went off of Korea, 28 versus San Francisco, 16. So the water makes a big difference, the water temperature.
That has a lot to do with this equation.
Yes, it does. It has a huge amount because warm water goes into the air a lot easier. It's more excited than cold air at the surface. Add the lift, add the trough coming in, and you had perfect storm right there giving you humongous numbers.
It was the perfect tsunami in the sky. Well, is that pretty much everything you wanted to show us?
I think so.
It's very comprehensive. Thank you very much for that. It was very interesting. Surprising that we don't get a little bit more detail on the news channels, or maybe on the weather channel. I don't know. I don't watch that.
They can't give you that. They only have 30 seconds to give you the weather.
Yeah, I suppose. But, I mean, that's fairly extraordinary. You'd think that they'd just take a bit of a snippet whatever.
Well, it took me several hours to figure all that out. It's not that simple. Geography is always challenging because you don't know the place, but I'm learning Australia really, really well, actually.
Yeah, well, good luck. Yes, it's an unusual place. Our mammals lay eggs. But anyway. All right, well, I think we've just about wrapped that up. Thank you very much for tying that with a bow for us.
It's been my pleasure. Thank you very much.
And we hope that you've enjoyed this very detailed meteorological forensic episode of Whether or Not about sky tsunamis. And we look forward to bringing you some more information in the future in this great detail, or in our Skywise series, where we go from ground level up, diving into the sky. So thank you for that, Jeff.
Thank you.
And we shall catch you all very soon. Take care, everyone.